Hello. Good afternoon. Narinig niya ako?
And yun, sir.
Ayun, ay sorry, ang dami ko na pala nasabi. Medyo di mo pa na marami nasabi, pero ayun. Okay, ulit. Okay, so for today, we will discuss itong basic concepts of control systems engineering. Okay, in which ayun, i-discuss natin itong mga topics na to as much as we can. Although I can actually discuss this okay using recorded lectures kasi may available recorded lecture naman ako for this one. Still I would like to discuss them personally para mas natin mas so that we could talk things out okay with regards to this topic. Okay, so ko lang sandali let me just wait lang Okay, so here are the things that we have to remember about your control systems. Okay, so first things off, control systems are integral part of modern society. Okay, we can see many applications of control systems. Okay, in everyday life. Okay, in everyday life and even in some of the technological advancements that we are encountering every day. Okay, so with the rockets firing, space shuttle lifts off to the Earth's orbit. In splashing cooling water, a metallic part is automatically machined. Okay, a self-guided vehicle delivering material to workstations in an aerospace assembly plant glides along the floor seeking its destination. Now, probably this might be something that you are not really seeing in everyday. Okay, because it's not every day that you can see rockets fire. Okay, it's not every day that you can see machine parts being assembled or being done okay with accuracy. For example, yung mga nuts and bolts na ginagamit to stick materials together. You know that they are being manufactured by some methods, but you really don't see them every day. Okay, or you really don't see every day that autonomous vehicles okay are being used okay in order to say, for example, move materials or move people around. Okay, but in your own everyday lives, you can actually see this you can actually see this you can actually see this ayan. You can actually see this technological advancements. Okay, and they are actually applications of control systems engineering. Okay, dun sa recorded lecture that I'll be assigning you later on with regards to this one. Ipapakita ko sa inyo kung ano yung isa sa mga sinasabi kong applications na to. Ito yung if you have heard of Elon Musk's company, yung SpaceX. Okay, in which it's the main business of this company is to create rockets. Okay, you might have recently heard Elon Musk big experiment last week in which he attempted, or the company attempted, to fly a Starship line of rocket, okay, in which it's a Starship is that line of SpaceX rockets, okay, that is heavy duty, malaki siya, which can transport many malaking payload. It can transport very large amount of payload. Okay. Yun. Pero what you might have heard that that rocket actually exploded. Okay. In which Elon Musk doesn't consider that as a failure, but rather it actually had source of data. Okay, kasi ang ina-attempt nila kasi doon is yung katulad nung na-achieve nung Falcon 9 series rocket nila. Okay, wherein yung rocket nila, kasi ang Falcon 9 is a two-stage rocket. Okay, dalawang stage na rocket siya, in which the first stage can actually return to the ground safely. Okay, para ma-reuse siya. Okay? Kasi normally when you have rockets, in order for you to be able to fly it very far, to fly it at a very far distance to the earth, okay, from the earth pala, you need to use multiple stages of rockets. Okay? So in the case of Falcon 9, since ang trabaho talaga ng Falcon 9 series is just to put people into low Earth orbit. Okay? Ilagay lang yung cargo or people into low Earth orbit papunta sa International Space Station. Maliit lang siya, okay, and it's just a two-stage rocket. Okay. Now, the good thing about this, or the best feature of this Falcon 9 series rockets is that yun nga, yung first stage niya can actually return back to Earth in an upright position. Okay, so siguro dun sa lecture that I would be showing you in a later time, you would be seeing that Falcon 9 series in action. Okay, so that one is an application of a control systems. Although that is for rocket science. Although marami din sa mga magiging example natin later on deals with, say for example, deals with rockets or helicopters or airplanes or ships. Okay, yung pag-i-stabilize ng ship para hindi siya tumumba sa dagat. Okay, those are the things that we can those are some of the examples that we will deal with later on. Okay, so we are not only the creators. Okay, we are not only the creators of automatically controlled systems. Okay, we also have systems that exist in nature. Okay, so within our bodies are numerous control systems. Okay, so basically yung immune system natin, nervous system, muscular system, these are built-in control systems within our body. Okay, they regulate everything from movement to the way we think, to the way we perceive the world, okay, to the way we fight diseases. Okay, so these are automatic control systems, and the thing is that some of these or the manner or the principle by which these natural control systems are operating. For example, yung nervous system natin, okay? They're actually adapted, or yung kung paano siya gumagana. Okay? For example, yung nervous system, kung paano gumagana yung nervous system natin. That mechanism is actually being adapted into our machines today. You might have heard of neural networks. Okay? You might have heard of neural networks. Neural networks are or artificial neural networks to be more precise. Okay? These artificial neural networks, okay, are actually are computational algorithms that mimic how our neurons learn things in order to produce a certain output given a certain set of inputs. Okay? So, in this case, this is based on our nervous system. Yung ating neurological nervous system in which in the manner by which it learns, okay, the manner by which human learns, okay, to do certain tasks is adapted, okay, towards machine naman. Okay, so yun yung natin, yun yung advantage nung doon na develop yung natin ngayon, yung control systems natin ngayon. From the classical control systems engineering papunta sa non-conventional control, which uses some of the naturally occurring control systems that are in place. Okay, so one of which na nga is, for example, itong neural networks. Okay, now let's define what a control system is. So, a control system consists of subsystems and processes or plants assembled for the purpose of obtaining a desired output with desired performance given a specified input. So, isa-isahin natin yun, no? Let us define each of those things. Okay. So, first, subsystems and processes or plants. Okay. Your control system may be interconnection of different components. Okay, so it may be you may have different components. Okay, component 1 and then component 2 and then component 3. Okay, interconnected in some way. Okay, one way or another. Okay, in order for you to complete to have a complete system. Okay, so we might be representing your system, or we might be representing your control system using a block diagram, okay, or using a single block, something like this one. Okay, but this may actually contain one or more components inside this, and they are connected in one way or another. Okay, so yung isang control system natin may not actually be consisting of just a single system. It may actually be consisting of different components that are connected. Okay. Now, the main character in that system, okay, is what we will call the process or the plant. Okay, depende sa whether that system is actually, or that component is actually a process, which means it can be something that is measured within the system. Okay, like for example, a level, pressure, or volume, or flow rate. Okay, those are processes, okay, that can be measured, or are those things that are being trying to that your system is trying to control. Okay, so processes yon, or plants, maaring talaga sila tangible components talaga sila, like motor, like stabilizing system, for example, para sa mga aeroplano or sa mga barko. Okay, and these are the things that these are the main components. Okay, itong processes or plants na to are the main components that that your system operates on. Okay, so that's the first part of our definition. They consist of subsystems and processes or plants. Okay, assembled. Okay, now what is the purpose? The purpose is to obtain a desired output with a desired performance given specified input. Okay, so when you say desired output, okay, when you say desired output, okay, one thing, when you say output, okay, when you say output, it means, when you say desired output, it means it is the output that that is expected of the system. So which means kung expected ito, desired output itself, the desired output. Okay, the desired output itself. It is expected of the system. Which means for you to be able to set expectations. Okay, for you to be able to set expectations. Yung desired output ninyo is something that you would have to tell the system to achieve. Gusto mo ito yung ma-achieve ng system mo, itong desired output. So basically, this desired output is your input to the control system. Ito kasi yung sasabihin mo doon sa system na ito ang gawin mo ha. Ito ang gusto kong mangyari. Okay, that's desired. When you say desired, that means gusto mong mangyari. Okay. Although by definition, response, okay, take note pag-iiba-ibayin na natin. When you say response, okay, when you say response, this is actually an output. Okay? This is actually an output. Pero pag sinabi niyong desired response, or basically desired output, it's actually an input or a command. Okay? Mas tama yung term na command para dito. Okay? Command is a more appropriate term here. Okay, not really input. Kasi pag sinabi mong input, pwedeng signal lang yan. Okay, pero when you say command, meron kang certain target that you need to achieve. Okay, and that certain target that you need to achieve is actually the command. Okay, so basically, a control system is something that you have to command, okay, or you have to send commands to in order for it to behave in a certain manner. Okay? Now, once you have commanded or once you have sent your commands, okay, or your desired response to your control system, the control system should respond. Okay? So the system should respond actually. Okay? So the thing is, it is possible that this actual response and this desired response, okay, yung naging response ng system ninyo at saka yung gusto nyong mangyari sa system ninyo, okay, these two things may not necessarily be the same. Okay? Pwedeng, halimbawa, nagmomotor kayo, no? Halimbawa, nagmomotor kayo. So, kung nagmomotor kayo, tapos medyo kabig niyo yung motor niyo ng konting pakaliwa. Okay, ng konting pakaliwa. That's the command. Okay, yung pagkabig ninyo sa motor ninyo so that it could turn left. Okay. That's the desired response that you would like because you would like your motor to turn left. Okay? Pero it doesn't necessarily follow that when you turn your motor left talagang left kagad yung pupuntahan niya. Of course, it would follow a certain path. Okay, because you really don't because the motor may have some dynamics that would not allow it to actually turn left agad-agad. Okay. So there is a difference between the actual response and the desired response. Okay. Pero remember, magkaiba ang desired response sa actual response. Okay? The desired response is basically the command that you send to a control system, okay, in order for it to achieve or to try to achieve, okay? The actual response is what the control system actually had obtained or had attained, okay, as a response to your command. Okay, maliwanag ba yun? Okay, walang nag-respond Nandiyan pa ba kayo? Okay. Now, let us consider an elevator. Okay. Halimbawa, ito yung example. This is the most example that I am giving my students every lecture like this one. Okay. So let's consider an elevator. Okay. When the fourth floor button is pressed on the first floor. Okay. So basically, that manner of you pressing the fourth floor button, okay, is actually your desired response, because you would want your elevator to change its position from the first floor towards the fourth floor. Okay? So that's the desired response that you would like your elevator to have. That is, the final position should be on the fourth floor. Okay? So basically, that's also the command of the instruction that you have sent your elevator, that the elevator should go to the fourth floor, because I would want to go to the fourth floor. Okay. So basically, that's your desired response or command. Okay. Now, the elevator, what happens then is that if the elevator is ready, the elevator rises to the fourth floor. Okay, with the speed and floor leveling accuracy designed for passenger comfort. So parang what happens is that if this is you at the start, okay, as the elevator travels up to the fourth floor, its position changes in this manner. Okay? So, yun yung susundan yung curve. Okay? That is how the position would change over time. Okay? Until such time na this is the fourth floor. Okay? This is the fourth floor. But your elevator would stay at a certain level. Okay? That is very near the fourth floor. Okay? So, parang ang mangyayari dyan is that this is your fourth floor. Ito yung sideways profile niya, no? This is the car of your elevator. Okay. So, more or less, ito na yung elevator ninyo. Okay. Ito na yung part na kung saan nandito to. Okay. And this is your fourth. Wait lang. Okay. So, this is the floor of the fourth floor. Okay. Then, this is your elevator. Okay. This is the car of your elevator. Okay. So, this is your elevator. Then, this is fourth floor. Okay, and this is the car of your elevator. Achieving now a certain position, okay, which is slightly below the floor of the floor of the fourth floor. Okay, so assuming na lang natin na itong difference na to is actually insignificant, that you don't really need to yung hahakbang ba kayo para kuwari konti lang yan, siguro sabihin natin few centimeters, like for example 1 or 2 cm. That difference, itong difference na to is just 1 or 2 centimeters that you don't really have to notice it. Okay. Pero the thing is that upon issuing the command, okay, which is to go here, okay, your elevator did not actually just directly go from first floor to fourth floor. It actually went smoothly, okay, over time until it reaches this part. Okay. Now in that case, this is now what we call, okay, the actual this curve, okay, is now what we call the elevator response. Okay? Or the elevator, or specifically this is called the elevator time response. Time response because the output, okay, response means output, okay, the output means the time response, because that output, okay, the response changes over time. Okay, so nagbabago yung position niya. In this case kasi the response corresponds to position. Tandaan natin that response describes a certain quantity. Okay, so in this case that quantity is the position of the elevator. Okay, so if we now plot yung position ng elevator over time, ito yung makukuha natin. Okay, so we see that the position, okay, of the elevator changes over time. Okay, so That is why it's called time response. Okay, the response of the system with respect to time. Okay, so now this time response, okay, or the change in position over time of this elevator, has two parts. Okay, meron siyang two parts basically. We can divide this into two parts. Okay, one is the transient response. Okay, that part of the response wherein your elevator is attempting to reach from the first floor up to fourth floor. Okay, that's the transient response. Okay, and the second part is this. Okay, the steady state response. Okay, now later on i-define natin yung dalawang yan. Okay, we will define those two in terms of their mathematics or in terms of their math. Okay. Pero basically, sa madaling sa pinakamadaling sabi, your transient response is the immediate reaction of the system to a certain input command. Okay? Which means once kasi that you commanded the system to change a certain quantity, like for example in this case position. So tinuman natin ngayon yung system natin to change its position. Okay? The system would take time, okay, in order for it to actually go to that desired position that you would like to where it to be. Okay, in the case of elevator, hindi naman, again, ang sinabi ko kanina, hindi yan agad-agad pupunta from first floor to fourth floor. Hindi naman yan magte-teleport, okay, from first floor to fourth floor. What it would do is that eventually it would try to achieve that position ng fourth floor. Okay? So that time or that output or that part of the response that is where your elevator tries to achieve that position from first floor to fourth floor is the transient response. So that's the immediate reaction. Okay. Now, when your response, when your response now settles to near to be at or near the input command. Ibig sabihin, kapag ka nandun na siya, okay, or malapit na siya dun sa kung saan gusto natin na yung system natin is commanded to achieve, okay, if it settles to be at or near the input command, because you don't really have to necessarily have your system have the exact value of the command that you have inputted it in. Okay? Halimbawa, kung katulad sinabi ko kanina, yung elevator nyo, pwedeng hindi siya sumakto dun sa fourth floor. Meron siyang konting difference. Okay? Meron siyang slight difference. Pwede naman yun. Okay? O kaya, yung in terms of your motor, hindi. Ang motor hindi pwedeng kailangan eksakto. Pagka dinesign ng motor, eksakto dapat siya. Pero in terms of, say for example, yung crane, okay, kung meron tayong crane halimbawa, okay, that carries, for example, a certain load, okay, from here, say for example, to here, okay. So halimbawa gusto natin yung umikot ng 180 degrees, okay, that's the input command, okay. But what it can achieve is actually 179 degrees. That's the actual, okay, or the actual angle achieved. Okay, pwede naman yan na meron silang konting difference. Okay, so if you would be seeing, okay, ito yung angular displacement nila, okay, ito yung time. you might command it to achieve 180 degrees, pero eventually ang ma-achieve niya lang is 179 degrees. Okay. So okay lang 'yun. Basta it settles at 179 degrees. Okay. That's the second part of your response. Okay, that's the second part of your response, which you will call the steady state response. Okay. Now, the correct term to use here is settle. Okay, kasi many students that define the steady state response as where the response is stable. Okay. Ang common na ginagamit ng term ng mga students to define steady state response is related to what we call yung stable. Okay. We don't use the stable in this case. Okay. We don't use stability in this case. Okay. Mali yung usage ng stability dito. Okay. More of settling. More of it settles on a certain value rather than stabilizing on a certain value. Okay, so mali yung stabilizing on a certain value because we will use stable or stability in another context. Okay, and that context doesn't apply in this case. Okay, it doesn't apply for steady state response. Okay, although later on pag-uusapan natin that how your steady state response behave is related to how stable your system is. But the steady state, stability stability to describe the response of your system does not apply for the output. Okay. If we are talking about the output, we don't say stable. Okay. It's more of settling, or it's more of it settles. Okay, or it's more of achieving equilibrium. Yun yung mga mas tamang term kaysa sa sabihin nating nag-i-stabilize. Okay? So, ayun. So, these are the two parts of your response. Okay? These are the two parts of your response of your system. Okay? When you have a control system, your system undergoes a transient response and then eventually settles, okay, to achieve the steady state response. Okay? Is that clear? Okay, sige. Now, in this case, okay. So, sige, thank you. In this case, we now measure, okay, kasi what we do, what we want to do as control systems engineer is that we control these things. Okay, we want to control this performance, or we want to have a certain level of performance for these things. And ano yung mga i-measure natin, or ano yung mga performance indicators ng system natin? Okay, we have two. Okay, number one, the transient response itself. Okay, we want to measure how fast your transient response, how fast your system undergoes the transient response. Gaano kabilis ito? Okay, because we might want this to be fast. Okay, or we want it to be slow. Okay, or sometimes our transient response would actually go some oscillation or some overshoot. We call this overshoot. Okay, once na before it actually settles to a certain value. Okay, we might want to control how much overshoot it would contain. Okay, so we want to measure these things kung gaano siya kabilis, whether it's fast, it's slow, it has overshoot, okay, or it oscillates at a certain time, okay, and how fast it actually settles, okay, in order for us to say that our system is okay or not. Okay, so that's one thing. We measure the transient response. Okay. The other one, okay, is the steady state error. Okay. The steady state error is the difference, okay. Basically, the steady state error is this difference, okay, between the input or the command, okay. This is your command, and this is the actual. The difference between the command and the actual is the steady state error. Okay, so these are the major measures of the performance of your control systems. Okay, how fast your system tries to achieve the steady state response, okay? And the steady state error is the difference between the command and the actual settling value of your or the actual output of your system. Okay? Is this clear? Okay. So, sige. So why do we now build control systems? Okay. What are the reasons why we build control systems? We have primarily four reasons why we build control systems. So number one, power amplification. Okay. So number one, power amplification. Okay, which pertains to the fact that we can actually say, for example, lift heavy objects or control heavy objects. Like for example, in the case ng crane, okay, in the case of a crane where a man, okay, riding on a certain usually nandito siya sa taas. Okay, tapos nandito siya. It controls this crane, okay, where now your crane carries a very heavy load, which is to be transferred from one point of the construction site to another. Okay, so by using this crane, this man can lift this object, okay, this very heavy object, okay. So that's power amplification, okay. That's the first reason. Second reason is remote control. So remote control means you are on a certain location and you are trying to control another system in another location. Say for example, satellites. Okay? So yung satellites kasi natin usually has a certain position above Earth. Okay? So meron siya certain position. Like for example, distance from the Earth, okay? Its footprint, gaano kalaki yung sakop niyang footprint dito sa Earth, okay? And if these things, okay, changes, if there are changes because halimbawa may tumama sa kanyang rock, for example, or comet or asteroid, tinamaan siya ng this might be misaligned. Okay, so your role here is to actually send signals, okay, towards the satellite so that it would return to its original position. Okay, so that's remote control. Okay, number three, convenience of input form. When you say convenience of input form, it means the output that you are controlling is not the signal that you are trying to control is not really something that is tangible. Okay, one example of this is yung aircon, for example. Okay, yung aircon kasi natin basically has so this is your AC, no? Okay, so yung aircon kasi natin actually blows out air. Okay, and ano ba ang purpose natin ba tayo nag-aircon? To condition the air. Okay, usually that conditioning comes in the form of temperature. Okay, what we condition what the air conditioner or what the aircon conditions is the temperature basically. Okay, kaya lang you are not able to control the temperature directly. Okay, but how do you control it using the aircon? Okay, you use thermostat. Okay, you use thermostat. So in this case, ang input mo is basically an angular position. Kasi yung thermostat kasi pinipihit niya 'yan eh. Okay, pinipihit niyo yung thermostat. So therefore, angular position yung pang-adjust nyo. Okay, so by adjusting the angular position, okay, you can adjust the temperature. Okay, so again, by adjusting the angular position, you are adjusting the temperature. So that basically is a very convenient way of adjusting the temperature itself. Okay, so that's what we call convenience of input form. When you say input form, it means the input that you use to adjust the output or to control the output. Okay? So, you can conveniently change thermostats, okay, in order to control temperature. Okay? So, yan yung isa sa natin, sa example ng convenience of input form. Okay? And finally, we use control systems as compensation for disturbances. So, these disturbances, okay, are external, when you say disturbances, these are external or internal signals that affect the output. Okay. Although in this context, dito sa compensation for disturbances na to, this actually talks more of an external disturbance. Okay? An example of which is halimbawa ito, actually itong presence nung meteor or asteroid na to that can actually hit this satellite, okay, is a disturbance. Okay. But what the satellite can do is that after it detects that it has a change in its position, okay, because of this disturbance, okay, it can automatically adjust itself. Okay, yung kanina pinag-uusapan natin sa remote control, merong external input galing sa someone from the Earth station papunta dito to correct its to correct its position. Pero it is also possible that the satellite itself can detect and correct its position. Okay? Kapag naka-encounter siya ng change in position because of this disturbance. Okay? So that falls under number 4. Kung automatic niyang kayang i-correct yung position niya. Okay? In the presence of this disturbance. Okay? Another example for compensation for disturbance is this. Sa Earth, meron tayong mga parabolic dishes. Okay? That for the purpose of this one, sa satellite communication pa rin. Okay? Pero dito kasi parabolic dish to. Okay? And this parabolic dish has a very large area or large surface area. Kaya kapag humangin dito, madaling maapektuhan to kasi malaki yung surface area niyan eh. Katulad ng mga billboards, for example, natin sa EDSA, for example. Kaya kapag bumabagyo, itinataas yun. It's because it is really affected by wind because of its large surface area. Okay? So that is why when there is a presence of large wind or strong wind, we actually put the billboard up. Okay? Para hindi siya hanginin, para hindi rin matumba yung structure. Okay, same thing with this kind of antenna. Since these antennas, okay, are parabolic dishes, ang laki ng surface area niyan. So therefore, it will be affected by wind loading. Okay? So it may change, and the thing about this antenna is that it needs to be set at a certain what you call azimuth. Okay? Which means yung orientation niya with respect sa horizontal plane. Okay? Or with respect to the parallel to the ground. With respect to the plane parallel to the ground. Okay? So kasi nandun yung satellite na kinokontrol niya. So therefore dapat nakaharap siya doon. So meron siyang azimuth, meron siyang elevation. Okay? So sabihin natin azimuth na lang. Okay? Now, this azimuth can actually be affected by this, the azimuth of this antenna can actually be affected by this wind. Okay? But the thing is that if we actually subject this antenna to a control system, okay, so that is meron siyang system that actually controls that azimuth. Okay? Meron siyang control system that controls this. Even in the presence of the wind, this will not change. Yung azimuth niya would not change. Okay, by the way, both of these are specified as angles. Okay, naka-specify yan sa angle. Okay, yung elevation niya is how it is elevated in terms of this axis. Kung mataas ba siya or mababa siya. with respect to this axis or to that axis that goes to the ano. Okay, so by use of a control system, okay, you can actually maintain the azimuth and elevation of your antenna even in the presence of these strong winds. Okay? So, are these clear? Maliwanag ba itong apat na reasons why we build control systems?
Yes po, sir.
Okay. So, sige. Okay, now let's proceed with the next lesson, which is about system configuration. Okay, so there is a your control systems. Okay, we'll be talking about we'll be talking about classical control theory. Okay, so that is why yung natin, yung the configuration that we will be dealing with. Okay, the configuration that we will be dealing with in terms of your control system are also those that are traditionally used, or those are that are traditionally used in the context of control systems engineering. Okay, pero as I would like to inform you that as the technology grows, your control systems engineering also evolves, okay, into a more advanced study. Okay, and in this case, aside from this and these configurations that we have already here, or we will be discussing in here. Okay, marami pang available na configuration, pero yung nandito lang is yung ginagamit lang sa discussion ng classical control systems engineering. Okay, so there are two. Okay, there are two types of configuration that we will have to differentiate. Okay, pero later on we will be mainly using the only the one, kasi nga we will be dealing with automatic control systems or automatic systems pala. Okay, so we have the generic open loop system, okay, and the closed loop or the feedback control system. Okay, so kung titingnan nyo mabuti yung dalawang yan, if you would be taking a look at those two, okay, you would be seeing that the main difference is the presence of this one. Okay, which is what we call the feedback loop. Okay, ayan, ito, tsaka to. Ito, at saka to. So, papansin nyo na ang pinagkaiba talaga nila is yung presence ng feedback loop. Okay? So, let's discuss yung makikita natin. Okay? In the open loop and in the closed loop system. So, in the open loop system, we will have the input transducer, okay, the controller, the process or plant. And then we have the disturbances 1 and 2. Okay? We have the input, okay, or the command, and then we have the output of the control variable. So these are the definitions or the features of the diagram. So the input or reference signal is taken by the input transducer. Okay, the input transducer converts the form of the input signal to the form used by the controller. Okay. Usually, the controller is an electronic circuit. Okay. Although hindi sa lahat ng pagkakataon it is not always that your controller is an electronic circuit. Hindi sa magkakataon. Okay. But in our case, since we would like to design or we would like to control a certain system, we would have this controller as an electronic circuit. We will use electronic circuits to be your controller. Okay? And if this is an electronic circuit, okay, ang trabaho ng input transducer is to convert this signal, okay, into a form that is being used by your controller. Okay? If your controller is an electronic circuit, for example, then it uses voltages or currents, okay, in order for it to work. Kasi electronic circuit siya eh. So kung electronic circuit yan, malamang ang input nyo dito, voltage. Okay? So therefore, if this is not voltage, say for example, this is position, or this is angular displacement, okay, the main work, okay, the main work of your input transducer is to convert this position or angular displacement into voltage. Okay? Into voltage. Kasi nga, yung voltage yung gagamitin ng controller. Okay, so what would happen is that this input transducer would produce a voltage that is proportional to the position set here. Okay? So, that is the work of the input transducer. Okay, that is to convert the form of the input signal to the form used by the controller. So in this case, since your controller is an electronic circuit, okay, its input should be voltage. Okay, its input should be voltage, and therefore, the input transducer should convert anything or any input of this, whether say for example, position siya, angular displacement siya, flow rate, okay, or whatever, okay, i-convert niya yun papuntang voltage. Okay, is that understood? Okay, so sige. Now, the controller drives a process or plant. So basically, that controller is something that is connected to the process or plant directly. Okay. For example, kung ito ay motor, okay, this is a motor controller. Okay. Or if this is for example a compressor, okay. This is a circuit that controls the compressor. Okay. So, but then mamaya natin pag-usapan disturbance. Okay. And then this processor plants this is the main component or process of the system, okay, that produces the control variable. Okay. So, the processor plant produces the output itself. Okay. If your output is position, okay, then this process or plant produces that position required. Okay. In the case, for example, ng elevator, that position is produced by the motor and the car, yung mismong car assembly. Tapos yung motor na naka-attach dyan. Pati yung pulley system. Okay. Tapos yung motor niyan. Okay. That is your process or plant in the case of elevator. Kasama to. Okay. Kasi it also determines the position okay, of your elevator. Okay? So, bukod sa motor, ito rin kasama to. So, that's your process of plant. Okay? So, in the case, for example, ng aircon, ito yung compressor kasi siya yung nagbubuga ng hangin para lumamig or uminit yung isang kwarto. Or para lumamig yung isang kwarto. You don't use pala aircon to produce heat. Okay? At least sa atin sa case natin sa Pilipinas, we don't use aircons to produce heat. Okay, although in other countries they use the air conditioner to produce both heat and cold. Okay? So, sa atin kasi mainit lang kaya aircon pampalamig. Okay, sa kanila malamig, mainit. So, they use it to both heat the environment up or cool the environment down. Okay? So, that. So, in this case, the processor plant would produce the main output. So that is why, if you are to identify, for example, or if you are to make, or if you are to, if you are to, put a certain system into a block diagram such as this one, ilalagay natin yung isang system. Bibigyan kayo ng situation wherein you are asked to identify, for that system, you are asked to identify which is the input transducer, which is the controller, which is the process of the plant. Okay. The first step that you need to know is ano yung input signal ninyo, ano yung output signal ninyo. Okay. So, in that case kasi, whatever produces the output signal, once na ma-identify nyo yung input at saka yung output signal, whatever is the output signal or what component produces the output signal is your process or plant. Okay? Kung ano man yung component or kung ano yung system or ano yung component na nagpo-produce ng output signal niyo, okay, should be your process or your plant. Okay? So, also in the end, ito at saka ito, maaaring magkaiba siya. Yung input ninyo tsaka yung output ninyo, maaaring magkaiba. Okay? Sabi ko nga, sabi natin in the previous article that one thing that one purpose that we will build control systems is that we build it for the convenience of input form. Okay, so it is possible that the output variable or the control variable is not the same as that of the input reference. Okay, so naintindihan yan? Wala na ng respond. Andiyan pa ba kayo?
Yes po, sir. Yes po.
Okay, so sige. Baka medyo delayed lang. Okay. Now, disturbances, okay, as I said earlier, disturbances are unwanted signals that enter the system and alter the output. Okay? So, because this is a block diagram, we need a way for us to model, okay, what we call this model, okay, in order for us to model how your disturbance can actually enter into system. Okay, so in that case we use the summing junction. Okay, pag sinabi niyo this summing junction actually adds signal. Okay, so it adds the signal coming out of the controller, okay, and this disturbance. Okay, but remember that for your signals to be added, they should be of the same quantity. Okay, so remember again, for your signals for you to be able to add your signals, okay, they should be of the same quantity. Otherwise, kung ito ay orange at ito ay apple, you cannot add oranges and apples directly. Okay? So in this case, since ito lang yung nasa model natin. Okay? This is what is on our model. We need to remember that the output of your controller is in terms of voltage. Okay? The output of your controller is in terms of voltage. Okay? Therefore, para ma-add mo siya, your disturbance here should also be of voltage. Okay? So we should always remember that. Kung voltage yung output ng controller natin, this disturbance is also dapat voltage din. Okay? So in order to produce the voltage to control the process or the plant. So therefore, this disturbance one, okay, is actually something that is internal. Okay, internal to the circuit. Kasi in order for it to become a voltage, dapat nasa loob lang din ng circuit 'yan. Okay? Otherwise, hindi na siya internal disturbance. Or hindi na siya mag-a-add dun sa voltage that is produced by your controller. Okay? So the main characteristic of this disturbance is that it should be internal to the circuit. Okay? So therefore, this di ba nabanggit ko kanina that your disturbance may be internal or external? Ayan. Nabanggit natin kanina that your disturbance may be external or internal signals that affect your output. Okay? So, in this case, this disturbance one is an internal disturbance. Okay? Dahil nga, it adds up to the signal produced by the controller. Okay? And in order for it to add up, it means that the output of the controller, okay, and this disturbance should be of the same quantity. Okay? So therefore, this disturbance should be found inside the circuit or internal to the circuit. Okay? In order for it to add up to the voltage produced by your controller. While, okay, this disturbance too, okay, should be, again, para ma-add nyo yung dalawang signal, dapat pareho siya nung quantity nito. Okay? Nung ipoproduce ng process o plant. And again, the output of the plant is actually the output or the control variable. Kung ang output, kung ito ay motor, okay, it would produce here angular, it would produce angular displacement as an output. Okay, it will produce angular displacement as an output. Okay, which in that case, dapat ito rin, itong disturbance nyo, should also cause changes in angular displacement. Kasi para mag-add up sila eh. Okay, the main idea behind the summing junction is that it should add signals of the same quantity. Kailangan mag-add siya ng signals na parehong quantity. Okay, so therefore, kung angular displacement yung ipoproduce ng disturbance 2, this disturbance 2 should be an external, okay, an external disturbance. Okay, for example, wind. Okay, wind can alter angular or wind can change your angular displacement. Okay? So, katulad ng example natin kanina dun sa antenna position control position system o dun sa antenna position o sa azimuth ng antenna ninyo. If the wind blows, it would change it would cause the azimuth of your antenna to change. Okay? So, yung angular displacement na ipoproduce ng motor, nung processor plant ninyo, can add up to the angular displacement produced by the wind of this disturbance. Therefore, may iba talaga yung yung angular displacement ng system niyo. Okay. So in this case, for example lang, you have inputted that your azimuth changed by 45 degrees. So that's angular displacement. Okay? So yung 45 degrees na yan would be changed to a proportional voltage towards your controller para mapaikot niya yung motor ninyo to produce 45 degrees angular displacement. Okay? So let's say na-achieve niya yun, 45 degrees. Even in the presence of the internal disturbance. Sabihin natin negligible muna ito. Okay? So what would happen is that this 45 degrees may nag-blow na hangin. Okay, may nag-blow na hangin. So what happened is that it added 2 degrees, okay, of angular displacement dun sa ating antenna. So all in all, naging 47 degrees yung natin, yung ating output. Yung output angular displacement natin nung antenna, naging 47 degrees. So therefore, there is now a difference between the output and the input, which is something that we sometimes don't like kasi nga, kaya nga tayo nag-design ng control system para mawala yung disturbance na yan. Okay? So, naintindihan yung logic behind this one? Okay. Now, we can actually prevent this from happening, okay, by devising a feedback loop. Okay, devising a feedback loop here. Okay, so pag nag-design tayo ng feedback loop here, we can actually say na kaya natin kontrolin yung we can actually automate. Okay, we can automate things when we have a feedback loop. Okay, and number 2, we can actually compensate for disturbances, or we can actually ignore. Okay, depending on depending on how the controller is designed, we can actually compensate for disturbances. For disturbances. Because of this feedback loop. Okay. So, pero depende yun sa sa pagkaka-design ng controller ninyo. Okay. So what does the feedback loop do? Okay. It actually measures the output response. Okay, it measures this one. Okay. And then seeing that you have here a summing junction, that is the difference of this signal and this signal, which is basically from the output. Okay, it actually looks into the difference between the input and the output. Nitingnan niya yung difference between your input and your output. thereby producing what we call the error or activating signal. Okay? So that error or activating signal is what drives the controller. Okay. So in this case, what would happen is that the controller runs depending on how much difference there is between the input and the output. Okay? So kung malaki yung difference na yan, if this difference is large, so meron tayong large difference, okay, your controller is working very hard. Okay? Mas malaking so kung malaki yung difference na yun, for example ito yung signal ng difference na yun, the controller also produces a very large signal in order to drive the plant faster. Okay? Para ma-achieve niya para ito tsaka to magpareho. Okay. Now what happens is that if the output transducer measures that this signal eventually becomes very small, okay, lumiliit na yan kasi nga nagpapareho na sila ng reading. Okay, nagpapareho na ng reading yung input at saka yung output ninyo. Okay, what happens is that the output signal of your controller also becomes very small, thereby driving the processor plant in a manner that is not as powerful as before. Okay, so therefore, mas konti na yung magiging output niya, yung changes sa output niya. Okay, until such time that the difference is actually zero. Okay, the controller now stops sending controlling signals to your processor plant, and therefore, this output now stays the same. Okay, but that only happens when your input and your output are of the same magnitude. Okay, say for example, 45 degrees ito. Okay, sa umpisa, 0 degree yung kanyang azimuth. Okay, now your output transducer measures that this is a very large difference. Okay, malaking difference between 45 and 0 degrees. It would send a very large signal as your error or as your activating signal. In this case, this is called an activating signal. Okay, if these two are of different quantities, okay, they are called activating signal. But in this case, na pareho siya, okay, kasi degrees ito angular displacement ito. Angular displacement dito, so pareho siya. We can simply call this signal as error. Okay, so lagyan natin siya dito. We call that error, okay, if the output and input signals are of the same quantity. Kung pareho sila ng quantity, kung angular displacement yung input at angular displacement yung output, tawag sa kanya error signal. Okay? Ang tawag naman sa kanya ay activating signal if the output and input signals are of different quantities. Quantities pala to ha. Ayan, para tama yung grammar. Okay? So, ayun. In the presence of these sensors, itong output transducer at input transducer, it is likely, okay, pag meron kayong input transducer at output transducer, it is likely that the input and the output signals are different. Ulitin ko. If there is an input transducer, if your system employs input transducer and output transducers, okay, it is likely that the input and the output signals are different. Therefore, this is an activating signal. Okay, pero kapag wala nito, okay, at wala nito, or pwedeng meron nito, okay, pwedeng meron nito, okay, pero wala nito, okay, it is likely that the signal is an error signal kasi baka magkapareho lang to. Okay, pero in this case kasi, halimbawa sa very case na to na kino-consider natin. So whether you have input or output transducer, in-identify naman natin na yung input natin is an angular displacement, yung output natin is also an angular displacement. So therefore, pareho siyang quantity. Okay? Therefore, this is an error signal. We will consider this to be an error signal. So as I was saying, since malaking difference between 45 degrees na input at yung 0 degrees na output, okay, the error signal would be very large. Therefore, the controller will produce a very large voltage so that it would drive this motor. This process is now a motor. Okay, so it would now cause your motor to turn faster. Okay, so that ito, ma-adjust to ng mas mabilis. Okay, so halimbawa lang, after some time that this becomes now 40 degrees. After some time, naging from 0, naging 40 degrees na siya. We will notice that this 40 degrees, okay, and 45 degrees would have a smaller difference, a smaller error. So therefore, it would now lead for your controller to have a very small, to have a smaller driving signal. Therefore, it would also drive the motor with a small signal. Therefore, mas mabagal na ngayon yung ikot ng motor ninyo. Okay. Mabagal na siya kasi mas maliit na yung driving signal niya. Okay. So therefore, later on, sometime, na-achieve niya na yung 45 degrees. Okay. In that case, this 45 degrees and 45 degrees here, pareho na. So therefore, the error is now 0. And if the error is 0, okay, the control signal is also 0. Okay, therefore, the motor will stop. Okay, the motor now will stop. Okay? So, what would happen then? Kaya ngayon, pareho na siya, so mag-i-stop na yung motor niyo. Okay? So that is what happened. That is what happens when you have a feedback loop. Okay? So this automatic measurement of your output, okay, is achieved only by employing a feedback loop. Kaya meron kayong automation. Okay? Now, ito pa. Halimbawa ngayon that this disturbance would cause, halimbawa nag-blow yung wind. It actually caused your system to deviate by 2 degrees. Okay, so from 45, bigla ngayon magiging 47 yan. Okay. Now, with this sensor, with this feedback loop, madedetect niya that there is now again a difference between the output, 47 degrees, at saka input na 45 degrees. Okay, so magkakaroon siya ngayon ng error signal, something like this one. Okay. And then, what would happen is that the controller would actually again activate the motor to rotate. Okay, and then take note na since iba yung phase ng signal ninyo, in this case, okay, iba yung phase ng signal ninyo, it would also control the motor in a different manner. Okay, baliktad niya kukontrolin yung motor ninyo. Okay, so what would happen is that, pipilitin ngayon ng motor ninyo na umikot in spite of the presence of this disturbance signal that causes your output to deviate by 2 degrees, okay, para bumalik ulit siya sa 45 degrees. Okay, and that would always happen kahit na merong presence ng signal ninyo. So therefore, your feedback loop would cause your system to compensate for disturbances. Okay, is that clear? Okay, so closed loop systems, okay, then has the obvious advantage of greater accuracy than open loop systems. Okay, the closed loop system can achieve input commands in a more accurate manner than open loop system. Kasi sa open loop system, walang self-correction. Okay, your open loop system does not correct itself. What happens is that, basta ang mangyayari sa open loop system niyo is that kapag nag-produce na siya ng output, okay, your system doesn't have any idea on what the output is because it doesn't measure it. Okay, so closed loop systems are less sensitive to noise, disturbances, and changes in the environment, even changes inside the circuit, because over time, in 10 to 15 to 20 years, yung circuit na ginagamit natin to actually control ito, yung controller natin dito, in 10, 15, 20 years, that circuit that we use to design the controller will change Okay? Whether we like it or not, those components or the components of those circuits will change in value. Okay? So therefore, it will also change by the manner by which it actually controls the entire thing. Okay? Pero the advantage of your feedback loop or your closed loop system is that even if this controller also changes, okay, but not with with very drastic with not with very drastic values. Okay. Even if there are changes in the controller over time, it could actually it could still actually correct for those changes. Okay, so your system is basically is basically less sensitive to changes inside and outside. Okay, so you can control the transient response and steady state error. Okay, with greater flexibility in closed loop system. Okay, now in order for us to actually change those transient response and steady state error, we will what we can control here, okay, ang mababago lang naman kasi natin dito sa mga 'to is itong controller. Okay. So, your system may actually be performing with a certain transient response, okay, and steady state error. Okay, it may be performing with that level of performance. But you might want to say, uh, make it faster, okay, o kaya make it slower, depending sa requirements, okay. And in that case, the only thing that we can actually change, okay, in the best cheapest way, okay, is itong controller. Kasi actually, pwede mo palitan yung processor plant. Kaya lang, yan kasi yung main component mo eh. So, changing this would actually cost money. Okay. Whereas ito, simple circuit change um, can actually achieve what would you like to achieve with the performance in terms of transient response or steady state error. Okay. So pwedeng palitan mo yung plant mo. Okay. Pero gagastos ka talaga. Kasi in the case of this one, magpapalit ka ng motor. Okay. Paano kung malaking motor 'yan? Okay. So labor, pagbili ng motor, oras pa para mapalitan mo siya. Okay. That would whereas ito, magpalit ka lang ng op amp, okay, or magpalit ka lang ng mga resistors, ng mga capacitors, that would do the trick. Okay, so in most cases, what we would like to do is to actually redesign this controller. Okay, and that redesigning your controller or the process of redesigning the controller is what we call compensation. Okay, and the resulting hardware is called a compensator. So ang objective natin dito is to learn the objective of control systems engineering, okay, is to actually learn how to measure this first thing, how to predict this performances, yung transient response, tsaka yung steady state error. Okay, how do we predict them? Okay, how do we measure them? And then how do we actually design compensators in order for us to achieve a certain level of performance in terms of transient response and steady state error. Okay? Kasi yan yung ibibigay sa atin as requirements eh. So, may ibibigay sa atin requirements na dapat ganito lang ang transient response mo, dapat ganito lang ang error mo. Okay? And in that case, the easiest way or the easier way of actually achieving those objectives, design objectives, is by actually changing the controller. Okay? Kasi nga hindi natin option yung magpapalit ng control ng plant. Okay, that basically because would lead us to have a more expensive redesign, okay, or designing of your system. Lalo na kung nandiyan naman na yung system mo or yung plant mo or yung process mo. Okay? So, ayun, naintindihan ba 'yan? Okay. Although this is stated that the main disadvantage of using a closed loop system is the complexity. Okay, which is totoo naman kasi maglalagay pa kayo ng extra component compared dun sa sa open loop system. We don't really consider this as a disadvantage. Okay? For one thing, this disadvantage, okay, this disadvantage that the book is talking about overweighs what the benefit of adding a feedback loop achieves. Okay? Mas malaki naman yung magiging pakinabang natin kung meron tayong feedback loop kaysa dun sa paglalagay natin ng, say, for example, sensor. Okay? Sensor lang naman actually yung ilalagay natin eh. Okay? This is a simple sensor. Okay? Although it would increase the complexity, yeah, of your circuit. But that increasing complexity, okay, outweighs whatever benefit we can actually obtain from having a system that is free or less sensitive to disturbances, less sensitive to changes in the environment, okay, and can actually achieve what we can actually be flexible in terms of achieving the transient response and the steady state error that we need your system to achieve. Okay. And that disadvantage, okay, can actually be erased, okay, when you actually use computers as controllers. Okay? Kung computer yung gagamitin niyo as a controller, mas to, kasi your computer is a very flexible device. It can actually do many things. Okay, you can program it to supervise and to control many systems at once. Depende sa bilis nung computer mo. Okay, and at the same time, you can also use it for other purposes. Okay, so yung complexity nung although kailangan mo rin syempre ng converter ng data from the system papunta sa computer. Okay, so that actually increases the complexity. Pero again, the main advantage of your system being controlled by a computer is something that is really kumbaga parang parang malaking tulong siya dun sa iyo, okay, being someone that designs a certain control system, especially for malakihang deployment. Kung malaki yung deployment po ng isa kang industrial plant, you have many machines or you are operating so many machines in your plant, okay, and you would like to control the performances of each of those machines, okay, then using a computer for that purpose will actually be more advantageous in your case, okay, rather than looking at the cost, okay, of your at the cost of implementing a control system that uses the computer, okay, as the controller. Okay? So, maliwanag ba to?
Yes po, sir. Yes po.
Okay. So, sige. Now, we still have we still have 15 minutes to discuss. Pero siguro again, iwan ko na lang sa inyo itong dalawang to as recorded lecture na lang. Okay. And also, bukod diyan sa dalawang 'yan, i-start niyo na rin yung pag-aaral dun sa kasi we are behind the schedule kasi dapat nasa week 2 discussion na tayo ngayon. Okay, so since we are behind by a week in terms of the discussion, I would like you to start also. I-upload ko na rin unti-unti yung mga materials niyo so that pagdating natin nung pasukan or pagbalik natin sa January something, basta sa January, first week ng January, we would be able to discuss sakto tayo ngayon sa calendar natin. Okay, so iwanan ko sa inyo lahat ng mga materials for week 1, week 2, at saka week 3. Okay? For you to study. Okay? So hopefully daanan niyo yung mga material na 'yon. The material would include yung reading material such as this one. Okay? Yung recorded lecture. Okay? Yung recorded lecture, and number 3, mga homework. Okay? Mga homeworks for this one. And if you can check, actually, alam ko na, ibigay ko na yung homework ninyo. Halimbawa, tingnan natin yung notebook na yun. So, ito na. Meron na kayong homework 1. Okay, so, ayan. Now, ito lang reminder lang sa paggawa ng homework ninyo, ha. Sasagutan nyo siya dito sa, halimbawa, name 3 applications for feedback control systems. So, you would type in your answer here. Okay, so 1 are the applications. Again, answer in complete sentences, of control systems engineer or feedback control systems are something. So, diyan kayo magsasagot dun sa dito sa second row. Okay. Now, again, meron kayo, as discussed before, meron kayong dalawang options in order for you to answer this. You can type in your answers or you can scan. Okay, you can write your answers on you can write your answers on a piece of paper, then you can scan and then upload it here. Okay, kaya lang kapag mag-i-scan and upload kayo, remember lang na na sana mababasa ko siya. Okay. So, I hope na kung magre-resort kayo sa point na kailangan yung magsulat at mag-scan, please check if your your uploaded image of your answer is readable or not. Okay? Dahil pagka hindi kayo nabasa, I won't waste any time on reading them. Okay? Automatically, imamali ko na lang siya pag hindi talaga siya mabasa. Okay? And I wouldn't ask you about that. Ididiretso ko talaga siyang mali pagka ganun. So, make sure lang na kapag mag-i-scan kayo, mag-handwrite kayo, at saka mag-i-scan kayo at mag-upload, please make sure na readable siya. Okay? Na nababasa siya. Okay? Maliwanag ba yun? Okay. So, please check. Okay. Please check if you're, actually, dahil konti lang naman kayo, I can actually check. Ayan. So, lahat naman kayo meron ng homework 1. Okay. So, please do check if you have them. So, sir, pwedeng handwritten, pwedeng digital. Yes. Kung ano yung medyo mas sa inyo. O kaya pwedeng mix. Okay, kasi baka mamaya gusto niyo i-type yung iba, pero halimbawa may gusto kayong i-drawing, hindi niyo may drawing ng digital. So, mas madali sa inyo na i-drawing sa papel. Pwede rin naman 'yun. So, pwedeng yung text can be typewritten, okay? And then your image is hand drawn. Okay? So, it's okay na handwritten siya, pwede siyang digital. Basta ang reminder ko lang pagka handwritten siya or gusto niyo siyang i-handwrite, please make sure lang na pag in-scan niyo siya, mababasa ko siya. Yun lang naman yung reminder ko. Okay? So, ayun. Okay, any more questions? Baka may questions pa kayo?
Wala naman na po, sir.
Pwede po kumuha ng idea pwedeng kumuha ng idea sa answer sa lecture or on turn. Pwede kayong kumuha ng ideas sa answer sa lecture. Pero I would like you to explain them on how you were able to understand them. Okay? Ganun naman yun kasi magbabasa rin naman kayo ng materials. You would read materials from here, from other sources. You may combine them. Tapos pag pinagsama-sama nyo siya, then explain them in your own terms or in your own words. Okay? Ang ayoko lang din kasi is yung bibigyan niyo ako ng sagot na alam kong kinuha niyo lang directly sa libro. Okay, so yun, ibang usapan na yun kapag gano'n. Okay, okay lang kumuha ng idea sa libro, pero hindi okay na kopyahin niyo eksakto yung libro as your answers. Okay. So, ayun, yun lang. Sige. So, I think we can end our session for today at this point. Okay. And this would be our last meeting for this for 2020. So yung next synchronous meeting natin would be 2021 na. Okay, sa January. I don't know kung anong day ko siya i-schedule kasi sa ngayon hindi ko pa alam. Pero supposedly we can have a synchronous session on January 5, 2021. Pero titingnan ko pa kung we need to have it as scheduled on January 5, 2021. Okay. By the way, ito pala yung ano, no? May isa pa ako naalala pala. Ito yung sinasabi ko sa inyong soft due date at saka hard due date ng ano ninyo. Kung titingnan natin yung assignment ninyo, okay. May ito. So merong nakalagay diyan na due ng January 12. Okay? Yan yung soft due date. Okay, so ibig sabihin, pag nagpasa kayo on or before January 12, 11:59 p.m., okay yun. Okay. Pero, the homework would close on January 30. Okay, the homework would close on January 30. Kita ba yan sa inyo? Ayan, kita lang pala. Okay, so the homework would close on January 30. Which means, in between January 12 at saka January 30, pwede kayo magpasa. Although dito, ang makikita nyo dyan is late na turn in. Pero okay lang yun, wala namang kaso yun. Okay, pero sinasabi ko lang is that, after January 12, at nagpasa kayo, tatanggalin pa niya. Pero after January 30, hindi nyo na makikita yung turn in button nung homework niyo. Okay? So therefore, hindi na kayo makakapagpasa after January 30. Okay? So, ayun. Maliwanag ba yun? Okay. So, sige. So, ayun. Again, last meeting natin to for this year. So, again, I think we can dismiss na for today. Ingat na lang kayo sa mga susunod na linggo. I'll see you on January 2021. Okay. Happy holidays. Okay. So, sige. Pa-log out na lang sa meeting.
Thank you po, sir.
Okay. Salamat din. Ingat
Thank
kayo.
you, sir.
Ingat kayo. Pa-log out na lang, ha. Thank you.